Hello everyone, welcome to the channel. Today we will proceed to the part 2 of the video, that is finding radius of curvature. Today we will discuss how to find radius of curvature in polar form, and before discussing that we will introduce polar coordinate. Like in polar coordinate system, what we will do, we will specify the position of any point by giving two information. First of all, what is the distance of that point from the origin, and what is the angle between the positive direction of x-axis and the line joining origin and that point, that is theta. So the coordinate of this point can be written as r comma theta, and this theta is taken as angle from positive direction of x-axis plus x-axis. So for example, we can have a point whose Cartesian coordinate can be 3, 4. But then if you want to write its polar coordinate, then we have to specify its distance from the origin, that is r, and we have to specify the angle that the line makes with the positive direction of x-axis, that is theta. So in this case we can find r by finding these two distances, that is, this is 4 and this is 3. So this r will become 5, and theta can be written as tan inverse 4 by 3, and this will be 53 degrees. So in Cartesian coordinate, the coordinate of this point is 3, 4, and in polar coordinate, the coordinate of this point will be written as 5, 53 degree. This is polar coordinate of this point. Okay, now proceeding to finding radius of curvature, we will discuss, or we will recall, how we had found radius of curvature in Cartesian coordinate system. So what we have done, suppose we have taken a arbitrary curve. What we have taken, an arbitrary curve, and suppose we are wishing to define radius of curvature at this point. So what we will do, we will take small elemental part, and we will approximate this small elemental part dl as a part of a circle, and the center of the circle will be called as the center of curvature, and the radius will be radius of curvature. This angle will be d theta, and we will apply r equals to dl by d theta. Now there are two questions that we have to answer. The first question we can write as how we will locate a center if we have given a part of a circle. How we will locate center of a part of a circle, or we can write arc, center of an arc. The second question is how we will find d theta. How we will find d theta. So coming to the first question, the answer of the first question is that if we have a part of a circle, then what we can do at the end point, we can draw tangents and we can draw normals. Normal is nothing but a line which is perpendicular to the tangent. So this will be 90, this will be 90. And as we know, in case of circle, all the normals pass from the center. So the point of intersection of the normal at the end points will be center. So this will be center. So for our DL part, small elemental part, we will do what we will do, how to find the center of this part. We'll draw tangents and then normals, and the point of intersection of the normals will be the center of curvature. Now, how to find this angle d theta? This is our second question. So for the second question, what we will do, see, as we move from this point to this point, as we move from this point to this point, this normal rotates. As we move from this point to this point, our normal rotates by an angle of d theta, so that so as our tangent also, we can see that or I have also specified the fact that if a line rotates by some angle like theta, then the perpendicular also rotates by the same angle. Like suppose I have a line and suppose this is the normal. So if the line rotates by an angle theta, then it can be easily shown that this normal will also rotates by an angle of same theta by same theta from the previous position. So this angle will also be theta. So if a line rotates by theta, then its normal will also rotates by theta. So we will use the fact in our situation also. What we will do, how to find d theta, somehow if we will find what is the angle by which our tangent rotates. In this case, as we move from this point to this point, normal also rotates by d theta, tangent also rotates by d theta, because tangent is perpendicular to the normal. And if a line rotates by some angle, then its tangent, or sorry, if a line rotates by an angle theta, then its perpendicular also rotates by the same angle theta. So if a normal rotates by theta, then tangent also rotates by same angle theta. So in this case, if somehow we will find, if somehow we find the angle that the tangent rotates in moving from this point to this point, then we will find the d theta. So let's see how to find the angle by which tangent rotates. So what we will do, we'll take an arbitrary curve. Like suppose we are taking a curve like this, we'll take some point where we are wishing to find the radius of curvature, and suppose the coordinate of this point is r comma theta, means this is r and this is theta. Now As we move from this point to this point, suppose this point, the position vector of this point will become r plus dr. The position vector of this point will become r plus dr. This r vector and this is r plus dr vector and this is dr vector. And the magnitude of dr vector is nothing but dl, means our arc length. So if we talk about tangent at this point, if we talk about tangent at this point, the tangent at this point will be in the direction of dr. So if I draw tangent at this point, the tangent at this point will be in the direction of dr, and the tangent, suppose the tangent makes some angle with uh, the r vector, and the angle that it makes will call as suppose we are changing the thickness of this line so as to make the figure clear. We are taking this angle as beta. We are taking this angle as beta. Let me draw this figure separately so that our figure is clear. So this is our r, this is our dl, this is our dl, and this angle is theta. This angle is theta, and the tangent is like this. The tangent is like this, and this angle this angle is beta. So this also be beta, and this is the angle that the tangent makes with the positive direction of x-axis, and this angle can be written as the sum of interior angles, which will be theta plus beta, and we are naming this angle as phi. So phi is equals to, we can write theta plus beta, where phi is the angle that tangent makes with the positive direction of x-axis. Positive direction of x-axis. Now, as we move from this point to this point, what happens that the tangent gets rotated, because at this point the tangent will be something like this. So tangent will rotate. So how to find the angle by which the tangent gets rotated? So this is pretty easy, because if we differentiate this equation, we find the angle. We can write d phi is equals to d theta plus d beta. Why we are differentiating? One question can come to your mind. We are differentiating because at this place the angle that the tangent makes is theta, and at this place the angle, I said it wrong, the tangent at this place makes an angle phi, and the tangent at this place will makes an angle phi plus d phi. So moving from this point to this point, the tangent gets rotated by d phi, because at this point the tangent makes an angle phi, and at this point the tangent makes an angle phi plus d phi. So the tangent gets rotated by d phi. So how to find d phi? We have written d phi equals to d theta plus d beta. Now, how to find d beta in terms of d theta? So this is easy. We'll use some geometry. In this case, this is dl, this length is dl, and this length will be dr, because this is r and this will be r plus dr, r plus dr. So this will be dr. We talk about this length, then this length will be r d theta. So in this triangle, if we talk about this triangle, in this triangle, we can write uh, d beta. We can write beta as beta as uh, tan beta as we can write tan tan beta as r d theta divided by dr, and it will become r divided by dr by d theta, and we are denoting dr by d theta as r dot. So it will become r by r dot, where r dot is equals to dr by d theta. So tan beta is r by r dot. Now you also know that tan theta, sorry, uh, tan beta is r by r dot, and we can write, like, if we move this thing so we can create some space, like here we can write, suppose this is equation number 1, we can write tan beta is equals to r by r dot. We can differentiate on both sides. It will become sec square beta into d beta divided by d theta, and it will become square of r dot square r dot into dr by d theta. We are applying quotient rule, minus r into r derivative of r dot, something like this. Now, if r dot is dr by d theta, then r double dot can be written as d2r by d theta square, or can be written as derivative of r dot. So this thing will become r dot square minus r double dot divided by r dot square, and this thing can be written as sec square beta multiplied by beta multiplied by d beta, and this thing can be written as d theta. So we can also find directly d beta. So d beta is something like this. Now we will put this value in the equation 1, then we will have d phi, and d phi is nothing but d theta plus d beta, and d beta is something like this: r dot square minus r double dot divided by r dot square into d theta divided by sec square beta, and this will become d theta into uh, 1 plus r dot square minus r double dot divided by r dot square, and sec square beta is nothing but 1 plus tan square beta and 1 plus tan square beta. Tan beta is nothing but r square divided by r dot square. So the expression is huge, but we have to write d theta into will become 1 plus r dot square minus r double dot divided by it will become r dot square plus uh, r dot square plus r square, and this thing will become d theta into r dot square plus r square plus r dot square minus r double dot divided by r dot square plus r square, and this thing can be written as d theta multiplied by r square plus 2 times of r dot square minus r double dot divided by r square plus r dot square. This is d5. Now we have found d5 now, so we can find then radius of curvature, as we have known the angle by which the tangent has rotated. Like the tangent has rotated by an angle of d5, so normal has to be rotated by the same angle, and the angle is d5. So and this is the dl, and from the previous figure also we can find the dl. We can write dl as, from this figure we can write dl as uh, under root of dr square plus r square d theta square. See, see this triangle. This dl can be written as base square plus perpendicular square. So dl can be written as d theta into under root of r square. This thing can be written as d theta under root of r square plus dr by d theta whole square. So dl is, we can write dl again. dl is nothing but d theta into under root of r square plus dr by d theta whole square, and uh, we had mentioned that dr by d theta is nothing but r dot, so it will become r square plus r dot square. So radius of curvature is nothing but r equals to dl by d5, and dl is nothing but d theta into under root of r square plus r dot square divided by d5 is nothing but r square plus twice of r dot square minus r double dot divided by r square plus r dot square. So multiplied by d theta, so d theta will be cancelled. The expression will become r square plus r dot square to the power 3 by 2 divided by r square plus twice of r dot square minus r double dot. So the final expression of radius of curvature, let's denote radius of curvature by capital R in order to avoid confusion. Okay, we are denoting radius of curvature as capital R. Yes, here as you can see. So the expression for the radius of curvature and polar coordinate system is something like this: r square plus r dot square to the whole 3 by 2 divided by r square plus twice of r dot square minus r double dot. here we have to mention r dot means dr by d theta, and r double dot means derivative of r with respect to theta. So that's all. Hope you have understood the topic, and see you next time, next video. Okay, bye.